Your microphone's working well. We can hear your keyboard.
Well, I think I just hit the mute all button there, so that'll put the kibosh on that.
Cool.
Good morning, good afternoon, or even good evening, depending on where you are in the world. My name is Michael Carducci, and I want to welcome you to the latest in the No Fluff Just Stuff series of community webinars. And I am extremely pleased to be joined in the studio today with Dr. Venkat Subramaniam. And our topic is 5 ways to improve the quality of your code. And let me see if I can add him in here as well. Welcome, Venkat. How are you, sir?
Hey, Michael, good to see you. It's a great pleasure to be here. I can't tell you how eager I am to get the conference circuit going so we can actually meet in person. But in the meantime, I'm delighted to be meeting this way.
And you know, it looks like we are seeing light at the end of the tunnel. Of course, we do have the next No Fluff Just Stuff virtual tour stop right around the corner. That's April 30th. So do check that out at nofluffjuststuff.com. But we are beginning to schedule some of the upcoming shows in the fall, beginning in September, in a hybrid format. UberConf is happening. I see you're rocking and representing the UberConf speaker shirt there. That's going to be happening in October as well. All of this, of course, is available at nofluffjuststuff.com. But I want to get into the meat of the topic here. And, you know, a while back, one of my old bosses and I, we sat through and we put together just a list of truths in our industry. And, you know, there are a lot of these, like future, you know, later means never, temporary means permanent. And one of them was future you already hates the code you're writing today. And we've all been burned in that experience. We've all gone back a year or 6 months or sometimes even 1 month later. And you're looking at this code, shaking your head, pounding your fist. You know, what jerk wrote this? Get blame. Oh. And of course, this is probably why some enterprising soul created a little tool called Get Blame Someone Else, but that's a different topic for a different day. So as developers, though, this is a really interesting topic. What we want to write better code for ourselves, for our peers, just to avoid the inevitable downstream problems. And I want to start with this question for you. What does it take as a developer to write better quality code?
You know, Michael, you were saying about your boss and the words of your boss, but you reminded me of something that I like to say. Do stuff today so the future you thanks you. And that's one of the things I always emphasize is, you know, how many times we curse ourselves and say, darn it, why did I do it that way? So you know, occasionally, this is very rare for myself, when I can wake up and pat myself on the back and said, I don't know why you did it, but you did it good that day. So I want more of those moments. But I would say there are 2 different reasons why I really want to care about code quality. And, you know, we all talk about agile development, and agile has kind of gotten its own notoriety over time. People are doing trying to be agile or do agile, even worse case, for different reasons. But if you really think about the spirit of agility, it is for us to be able to make change affordable even late in the game. Now here's the deal, right? You're sitting at your meeting and your team is talking about having to make a change to that XYZ module. And you realize the last time you touched the XYZ module, you couldn't go home for the weekend. You're going to resist as much as you can from making the change to that module. So the first and foremost reason I would say we should care about code quality is, you know, really to be agile and to be able to respond to change. But one of the things, to go back to your question, is, you know, I would say, you know, this became really shocking to me in my career when I started programming, you know, out of school. This was a good 30 years ago. And I had been writing software for a few years. And this was commercial application, you know, making millions of dollars for the company. And these were controlling refineries, you know, God forbid, people may die if things go wrong. and nobody cared to review the code. And I wrote my very first book, and the amount of reviews I got from that particular book by technical editors just blew my mind. And I thought that day, here's the book I'm writing, and it's going through a rigorous review, but there is a software I'm writing for commercial, products, and nobody seems to care about it. Why would it be that way? And part of the reason is developers tend to, I'm not saying everybody is, but a lot of developers tend to, paint themselves in a corner and say, hey, I'm good. I know what I'm doing. Leave me alone. And I think to have that humility to say, hey, I'm good at what I do, but I can learn a lot more. And I want to really improve every day. I want the tomorrow of me to be better than the today of me. And if we can have that attitude, I think we can create better software, better code. And it's that willingness to listen, willingness to change, I think is one thing I would hope that more of us would have along the way and not forget it as we become, more senior developers.
And, I think you really hit the nail on the head on a few of those topics. And there's some really great conversation happening in the chat right now. I've been following a little bit, but one that popped out was too many coders enjoy writing obfuscated, complex, hard to understand code. And so this follows on to some things it gives them job security. Some just don't want to make it easier for anyone else. I think there's a third reason in there. Sometimes we just want to show off. And it's like we've got something to prove. And that's been me. I have an entire keynote on this called Ego-Driven Development, which is just me trying to show off and prove that I'm great. And it wasn't until I stopped trying to be great and started trying to be better that my career changed.
It is true, because it's a misguided, pride we take. I always jokingly say, the developer goes to mom and says, Mom, I wrote this code today and nobody understood it. And mom gives a hug and says, I know you're going to be smart one day, right? And then that's the kind of misguided feeling we carry with us sometimes. And then we need to really go in the opposite direction and say, well, I wrote this code and darn it, everybody understood it. And I don't need to really spend more time on it, is what we need to really promote. It's a cultural shift we need to go through, I think.
And it's a different notion of intelligence and genius. I love this quote from Dirk Gently's Holistic Detective Agency by Douglas Adams. If you haven't read it, wonderful book, especially if you like Douglas Adams. But they were talking about this kind of somewhat disputed, but not, but also somewhat supported assertion that Sir Isaac Newton invented the cat flap, the pet door. And Dirk Gently, the titular character of the book, said that was a demonstration of his genius, of the true depth of his genius, is that he invented the cat flap. And the response that he got was, well, that's the most mind-bogglingly obvious, like smack you in the face, obvious idea. There's nothing genius about it. It's obvious. And he says, that's the genius, to take a hitherto non-existent concept, and once you've created it, it suddenly becomes blindingly obvious to everybody. And that's the level of genius that I want to aspire to. But yeah, that I want my code to be understood. And I feel like I've done my job right in that case. But I think there's a lot of practices that we're aware of, like just reading the chat. There's a lot of conversation, people saying, oh, unit testing, automated testing, and documentation, things like that. Yeah, obfuscated code makes me feel smart. But we know what to do, but knowing the path and walking the path, as Morpheus said in the Matrix, are different things. And it feels like we're under pressure to write good quality, stable code that ships on time and has all the features that are demanded. And, if we make that triangle, it's like you can pick any two: good, fast, cheap, or quality, features, and schedule. And everybody wants all three. And usually what gets sacrificed first is quality. So how do we do this as developers, as teams, How do we get that quality when we're under so much pressure? We're constantly being pushed to cut corners.
Well, I think the first step is actually truly realizing the why. And one thing I mentioned was about agility. We cannot be agile if the code is of poor quality. But I think there are two other really important reasons to consider. One is the first law of programming says lowering quality lengthens the development time. It's the ironic situation, right? You talk about wanting to deliver fast. We always want to deliver yesterday, and it turns out that poor quality code actually takes more time in the long run to develop the software. And I'll share with you something that I absolutely admire when people say sensible things, which becomes very rare in today's age. But I was talking to a company earlier this week, and they wanted me to convince their developers why they should follow some technical practices. And I was trying to convince them as much as I can. And one of the things the developers kept saying was, but it's taking time, but it's taking time. And then the architect intervened and said something, and I really sincerely appreciated his words. And he said, when you talk about time, he said, zoom out before you talk about time, he said. And that just blew my mind. And then he said, when you're talking about taking more time, when you zoom out, you realize you are shifting the time from one area to another rather than expending the time in one place. And I think that's a really important, way of thinking for a lot of people in organization. We don't have that maturity to think that we are actually shifting the time rather than spending the time. And his effort and his reason was, by shifting the time, you are spending more time on creating quality. And so you end up spending less time on maintenance. And so in the long run, you're actually gaining. And so he really wanted to bring that perspective of shifting the time. The other reason I sincerely say this is, we all talk about respect. And who wants to work in a place where we don't feel respected? Well, I think that one of the best way to communicate respect to fellow programmers is to show them that, hey, I care about you as a person reading the code. If you really think about it, we are good human beings, right? In at least in most of the civil world that we tend to live in. I mean, you and I and a lot of other people on this event right now, we travel internationally, so we see different cultures. But one thing we respect quite a bit is, in a civilized society, when you walk through a door, you don't even know who this person is behind you. It's a complete stranger. You may never ever see them ever in your life. But what do? You gently hold the door for a moment so it doesn't slam on them, so they don't have to push the door with effort. And then that's humanity that we carry with us. Well, every time you push the code, there is somebody right behind that code commit who is going to have to pull that code and look at it. So that respect is something we need to carry down to the code as we check in, I think. So to me, one of the really important reasons to write good quality code is to tell that fellow human being, you know what, I love you. I do care about you. I respect and honor working with you. I think that humanity is probably one of the important reasons really to write better quality code. And that's the reason I want to be putting the effort to write better quality code as well.
And I love that. I love that metaphor because it's just such a simple, kind gesture. It's not even kindness. It's just being considerate, and that's something we should just strive for anyway. In all of these, all of these debates, it's just, it's the considerate thing to do. And it's considerate for myself, and it's considerate for my peers. And I would want them to be considerate of me. But no, that's such a beautiful metaphor. I really like that. Now, as a developer, and this is how I spend my days. I write code. I'm a hands-on architect, and so I'm always in this world. I'm drawn to complexity. There's something in me that just I like puzzles. I like tackling hard problems. And I like challenges, and that led me to make a lot of bad decisions. But the other kind of the other pull that I have towards complexity is I tend to over-engineer and overanalyze things. And one of the most simple things that I overanalyze is I start with a premise. I want my code to be better. And I immediately go down this depth-first search of tools and metrics and statistics and plugins and linters and optimizers and all of these things. And I forget about the problem I'm trying to solve, and I dive right into the tools. I think these tools have their place, but what is your advice for where they best fit and how to let our problems drive our tools rather than our tools drive our problems?
Yeah, I want to switch the terms a little bit here, because when we give a better term, I think we get more motivated to do the right things. So I've started using the term capability instead of complexity. So I want my code to be capable, not complex, because complexity is a smell. We want to get away from it. I don't want my code to be simplistic. I want my code to be capable to achieve the solution it needs to achieve. And I want it to be extensible. I want it to deliver the results. So I want to favor capability over complexity. And if I can really come up with simplicity with capability, I think that's a better drive in general. But what I'm going to say here is nothing new, because everything knows about it. But as all we know, common sense is not common. Knowing something doesn't mean we actually do it, like you said earlier. And so I really want to focus on, 5 things that really motivate me every day to write better quality code. But in one way, I would argue one of the best ways to write readable code is actually to read it. So the more people read the code, the more code becomes readable as well. And if you really think about, why are relational databases so strong and solid? Well, part of the reason is because they've been put to use so often that any bugs that were there got killed over time. They just couldn't live that longer, right? So the usage really improves things. In a similar way, the quality gets better the more we can actually exercise that quality and more people read it. But in terms of that, I want to start with the first principle or the rule or what I would like to do is something I'm going to channel from somebody that I quite admire in his work, and that is Kent Beck. And Kent Beck outlines what he calls as 4 rules of simple design. So my first rule is his 4 rules in it. And so he outlines 4 rules for simple design. And I tend to really follow that almost every single day when I write code, when I write, test and write code. And the first rule he outlines is the code passes all the tests. I know that's kind of funny for some teams. He's assuming that there are tests to actually pass, but he emphasizes that the code passes all the tests. The second rule is the one that I admire the most, and I honestly strive really hard to improve myself, and I can definitely use more help to improve it. So the second rule he outlines is that the code reveals intention. And the third rule he talks about is that there are no duplication. And the fourth rule he talks about is the code has fewest elements, minimalism, parsimony, and such. And to me, that nicely distills the way to create quality software, in my opinion. The code passes all the tests. Well, that gives us 2 things. It helps to design the software in a way that it is testable. Oftentimes when I go to companies, they say, oh, we do automated testing. And I often say, let me take a look at it. And then they say, sure. And they open this test and they say, no. Let me look at your code. I don't want to look at your test. And the reason I say that is, if I can look at the code, I can tell you whether there is test written for it before or after. The code structure is significantly different when it's test driven versus when it's not. So, it's kind of like somebody telling you they go to the gym every day. You don't have to ask them to show the gym. You just have to ask them to show themselves, right? So it's kind of the same idea, is that the code actually reveals the structure of being
Mhm.
tested or not. So it's a design aspect that's reflective of the test. And of course, we get the regression benefit by having the test cases. But how many times, and this really goes back to culture, and honestly, this pains me. I have this, fortune, privilege, luxury, whatever you may want to call it. I work with absolute beginners to total experts in the industry. I spend my time at the universities. I go to multiple universities. I spend time with students who are just about coming out of high school, getting into programming, and all the way to very senior developers who are either close to retirement or just retired, right? And the whole spectrum between. And it really pains me to notice that people are so callous when it comes to giving variable names, when it comes to giving function names and class names. How many times people give names like P1, P2, K1, K2, W, Z, and K, and
Int I, int J.
it only got worse with lambda expressions, because with lambda expressions people often think, oh, I can always use this thing called X arrow. I mean, what in the world is X, and why would I need to know what X is when I look at this arbitrary code? Variable names reveal context, reveal intention. They provide an abstraction in it. And so if we can pause for a minute, and I'm never going to be perfect in giving a name, but I should at least make an attempt. Rather than calling it T, at least maybe call it temperature. And maybe somebody can come and tell me, maybe it should be something more than a temperature or something more domain specific. So the names have to be domain specific. That's the first thing. And that's one of the things I constantly try to remind developers is, take pride in giving names. I mean, would you name your child P1 and P2 and P3? Why, if you wouldn't name children that way, why would you name your variables P1, P2, and P3? So it's a matter of respect we give to ourselves by giving good names. So to reveal intention, to make the code expressive, and then of course to remove duplication where we can, and to have the fewest elements, fewer interfaces, fewer classes. And of course, one small problem with this is, if you want to go to the fewer elements, what if we create a ball of mud, a God class which does everything? And I think that's the beauty of what Ken Beck laid out. He put them in the order of priority. If you create a ball of mud, it won't be testable. So the priority order really places them in a good balance between each other. So one of the very first things I encourage developers to do when it comes to writing good quality code is to think about and follow Ken Beck's 4 rules of simple design. So I make that my very first rule among the 5 rules I want to talk about today, is to pay attention to Ken Beck's 4 rules of simple design and follow it through every step of the way, writing the code.
Oh, and there's one thing you said there that just speaks to me on such a deep level, and that is, let me look at the code. I can tell if you wrote your test before or after. So for so much of my career, I would hear all of the software development intelligentsia espousing the benefits of unit tests and automated testing and things like that. I'm like, yeah, this makes perfect sense. And then I would look at my code. How on earth am I supposed to write tests for this? Because this is calling out to the database here and then calling out to that service there and then doing this and taking all these things and munging them together and generating some kind of output. I'm like, how can I test that method? And so it was one of those things that I actually, there was a period of my career, that spans now 21 plus years, that I thought tests were like an idea, and it was like, in a perfect world we would do this, but in reality it's, it doesn't really work out. And and I would read the books on, clean code and all of this, and I would read about these patterns and how we should approach writing code. And I was like, I this seems like a really complicated way to structure it. I don't get it. I don't get it. I don't get it. I'm just going to keep writing my code the way I write code. And flipping that suddenly changed everything. That that it wasn't just that I had test coverage and therefore I was less likely to break something. My code was less likely to be broken to begin with because I had managed the complexity beast. But one of the things as well, somebody commented in the chat, one of my favorite quotes of yours, sir, and that is, make it work, then make it better.
Real soon.
And that's one of the other kind of challenges we created for ourselves. One of those challenges is if we follow MTAC, right? Maybe test after code, we'll see. If we follow MTAC, then we're going to struggle writing those tests, and those tests are not going to be as good, as robust, and we're going to have other issues there. But another thing that we do is we try to solve all of the problems simultaneously. And so, like, your make it work, make it better philosophy has been a kind of core guiding principle, but it's make it work, write the tests, make it better is kind of the process I follow. But would you take us through that real quickly before we move on?
Yeah. So one of the challenges we often deal with is we want to move the mountains to begin with, and we get stuck, we get intimidated, we get overwhelmed. And in all honesty, most of us want to make our code simple. Most of us want to make our code optimal. We want to really make it, so to say, good or better. But in all honesty, we don't know what that really is. And we may not even know what good is from where we are. So I like to really follow this principle, and I really train myself every day to do this, is make it work, but make it better real soon. And the real soon is important too, because you want to really make it work. And when a code works, a working code is much better than an idea in our mind. Mm-hmm. And once you have it working, the software exhibits this beautiful thing called the observer effect. The minute you see something working, you want to change it. And the definition of what is better becomes more relevant when we see something rather than hypothesizing about it without it in front of us. So when we make it work, we have better ideas of what better could be. And this is one of the reasons I love having the test cases. I'll share with you an experience I had years ago. This was a programmer who wanted to write, in all honesty, she wanted to implement something really complicated using Scala. And she was new to Scala. And the topic was a very hard topic. It's not something you could just write and walk away. And she said, I'm really worried about it. How do I write a good code that is going to be maintainable, especially in this language? And I told her, listen, I don't care about your code at this point, in all honesty, but what I really would like for you to do, if you will, is write tests for everything you are writing before you implement the code. That's all I'm going to ask you. And she was really good, and she did exactly that. She wrote tests and she wrote the code. And then when she got done, she came to me and said, there you go. What do you think? I said, that's great. Thanks for that. Let me take a stab at it. Now that she had a good amount of tests, I started refactoring her code. And every step of the way, as I refactor the code, the test is there to tell me that things are still working. And anytime the test were to fail, I would go back to her and ask her what the code was doing if it was not clear to me. And really, the test became the safety net for me to refactor. And so in this journey of make it work, make it better real soon, I think that's one of the reasons I love these automated testing. And I cannot tell you how many times, being a fan of functional programming, I work with developers in the industry who come to me and say, how do I write this code in functional style? And I always tell them, if you give me an imperative code with the test cases, I can make it functional for you. But if you give me an imperative code without any test cases, I'm really sorry, because we're playing a guessing game right now. So to me, the test cases are a feedback to tell me, yep, what you did is a good work and it's still working. And that's one of the reasons why that feedback loop is extremely important, so we can continuously improve. You might come 3 weeks from now and say, I got a better idea to improve it. I was giving a talk in a conference, and there were probably about 100 people in the room. And I was doing a talk on test-driven development. And I was telling about all these wonderful things about TDD, when a gentleman in the very back of the room raised the hand and he said, I wonder if you could make this change to the code. And I immediately said, that's the beauty of having test cases is we never have to wonder if your ideas have merit. We can actually try it. And I immediately saw his face just bloom. And he's like, whoa, that's pretty awesome. And I just made the change right away. The test passed. And I've never seen a happier person than that, right? So to be able to get that feedback that our ideas actually work or they don't is absolutely awesome, in my opinion. That's another reason I really care about that feedback loop.
And as part of that feedback loop as well, there was a comment here in the chat just a moment ago from Kevin said, let somebody else read it. We are not aware of our own opaqueness. And I think that is so true.
Yep.
I wrote it. Of course, I understand it. This is obvious. And I think the best decision that I've ever made on any team that I've been part of is to implement code reviews. Like that has changed everything. I am the least disciplined when I'm the only one touching my code. And I'm the most disciplined when I'm interacting with other people. Like on my own, I'm the worst programmer in the world.
I know this is a bit gross, so I apologize for saying it. I apologize ahead of saying it. But I tweeted this a month or two ago. This is one of the reasons I love the metaphor of code smell. Mm-hmm. And I tweeted saying, code smell is like body odor. It is rarely the case that we recognize our own odor, right? So you sit next to somebody and you're like, what's that smell? Unfortunately, the person who emanates that smell doesn't realize it. The code we write is exactly the same, unfortunately. It's very rare that we feel the smell or sense the smell of our own code. And that's one of the reasons why we want somebody else to read it. And then the more frequently they read it, the better it is. You're fine, Michael.
Okay. Well, I've been quarantined away for so long now. The only person around me is Kate, and she's probably used to my smell at this point. Interesting. Well, hey, George. So there's also some discussion about pairing and mobbing in here as well. What do you think of that as a process?
One of the best projects I worked on was a project I worked in Netherlands. And I was there for maybe about 3 months working with them. And one of the things the team did is something I absolutely admire for them to be actually able to pull this off. The rule in the team was that you switch pair every half a day. And the maximum you can pair with somebody as an exception is 1 full day. And the way this worked was pretty amazing. So imagine you and I pair today, Michael, mm-hmm. and you stay with the code, and I'm going to go pair with Dave, mm-hmm. and Sarah is going to come and pair with you. And so when Sarah comes to pair with you, she's going to ask the question, why are you writing the code this way? What was the thought process? And you start refactoring the code. When I pair with Dave, I'm going to ask the same question. And so this team did not talk about collective ownership. They practiced collective ownership on an hourly basis, on a daily basis, right? So we switched pair every half a day, pre-lunch versus post-lunch, and only as an exception did somebody pair for the entire day. And I really admire the courage the team had to really practice that, and all the resistance we hear about it were pushed away. And that's one of the best projects I worked on, honestly, in terms of agile being truly implemented rather than something we just talk about.
Well, and that's the heart of agile too. We get so bogged down in all of this. In fact, I spent 24 hours this week in safe meetings, and we're only part of the way through Friday. But agile is not about processes and bureaucracy and everything else. Agile at its fundamental core is about fast feedback. And I don't think you can get faster feedback than 2 people looking at the same thing at the same time. To the comment there in the chat, in pair programming and mob programming, your code review happens in the IDE as you're writing it. A lot of debate around the value of pair programming and if it's good or bad, or how do you make the case to the business. And I don't think we can get really deep into that today, but I do find I am significantly more productive in a mob or in a pairing situation, especially with fairly frequent changes, than I am on my own. I mean, it's so easy to get weeded on my own. It's so easy to kind of get stuck. And I think the economics of the time are not what they appear to be. I think the economics are better than they appear to be.
And that's one of the challenges, is that for somebody who doesn't do it, that's absolutely hard to imagine, right? And they're going to look at you and say, oh my gosh, that sounds horrible. I would never be productive in such an environment. And that's one of the things I often encourage teams to do is, if you're not used to it, give your developers 2 weeks and say, try it out, be very open, experiment. It's not a mandate for you to do it, but put your heart and soul into it and see if this is for you, and give it a best shot and see what you come out with. And it may not be for everybody, but for those who are convinced about doing it, I think they should really do it because there's benefit and they can carry it forward.
I'm throwing a comment in the chat here as well, because I don't want to go too deep into any down any of these rabbit holes, because we still have a few more strategies to get through. But so definitely getting that feedback, having other people look at your code, share that knowledge, basically getting that reading the code and having other people read the code. That is a very solid strategy there. And I think that's commonly overlooked.
It's a strategy, it's a solid strategy, but there's a fundamental issue with that strategy as well. And this goes back to what you mentioned earlier, right? For me to be willing to receive a feedback is really coming back to the humility, where I say, I am willing to improve so I can be better tomorrow than I'm today. That is not easy. Let's be honest about it, right? You and I, probably Michael, and a lot of other people who are, good in development, got so because we had that humility to listen and say, hey, I'm good, but I can be better. And I'm going to get better by making these changes. So I'm willing to listen to it. But that's not really easy for a lot of people, because they are in an environment where they got to defend themselves. They have to hold that authority. And to be able to say, by accepting I can change is not a diminishment of what I am, but only my willingness to get better. And I think that's a mental shift we have to go through. I can't tell you how many times I would talk to a developer and they absolutely are defensive because you are telling that my code is bad. It's like, no, it's not about you at all. It's about what we can collectively create. I want to be criticized for my code. In fact, that's one of the things I'm really worried about, is not that you will tell me to improve, that I'm worried that you won't, because that's the real loss, is if I don't get the opportunity to get better. This is kind of nicely segues into, I think, the second rule, which I want to emphasize really is to really write clear code instead of clever code. And I remember this one day, I was pairing with a developer and I had written a piece of code, and the developer looked at me and said, but why that code? And I said, look how awesome that code is. And immediately he said, Venkat, that's the problem. And I said, why? And he said, the problem is you are focusing on how awesome the code is, and I'm focusing on the lack of clarity of the code. And yes, it stinged a little bit because it's my awesome code you don't want there. But he was absolutely right. So we refactored the code so that it can be clear. And every single time I've written clever code, it's come back to bite me in bigger ways. And now, maybe this is a sign of maturity. Today, when I write a piece of code, my little brain says that's clever. I delete it right away. I don't want clever code anymore. I want clear code. And that is one thing. Clearness doesn't mean boring, right? Clearness doesn't mean pale. Clearness simply means that you are not challenging the intellectuality of the person who is reading it. You
Yeah.
are telling them, I care about you so you can get along your business to get things done. One of my most favorite books is The Design of Everyday Thing.
Yes.
And when I read that book, I shared that book with my children, and my elder son, when he went to college, he and I spent about a year, honestly, where he would constantly be texting me saying, "Dad, look what I found." And he would show me poor designs around campus where people would be struggling to open the door, what are
Yep.
called Norman
Norman
doors,
doors. Yep.
or things like that, where they're poor design. And he would constantly be giving examples to say how poor it is. And that is one of the things is, as Norman talks about in the book, it's an insult to the people when we design poorly, because a really good design removes that burden from the users of your design or architecture or whatever it could be. And we want to remove the cleverness from the code so it becomes obvious to the person who needs to maintain the code. And I think that is something we should really struggle for and strive for as well.
And I love that you mentioned that, and the analogy to design is so underappreciated. Although there are a lot of thinking folks on this call, a lot of plus ones on the design of everyday things. Somebody helpfully linked to that as well. If you haven't read this, it is a wonderful book, and it actually fundamentally changed the way I think about writing code. It might be one of the more valuable non-technical books that have made me a better programmer. But the analogy of design, I think, is excellent. And in fact, there is an analogy to clever code. And I think this is starting to get analogous to dark patterns and hostile design, which are very valid concepts in design. Hostile design is like at an airport, you wonder why they only ever have the bolted together rows of individual seats with the armrests. That is a deliberate design decision to make sure you're not sleeping on the seats. And that is hostile design. That's taking something that the individual would want to do and saying, we're going to make it really hard for you to do that thing. And then there are dark patterns where you're actually being deliberately opaque and misleading in your design. And these are pretty ethically dubious practices. And I feel like there's a clear analogy there between clever code and hostile design and dark patterns. And we should really evaluate forcing functions. I like that too.
So now I know why you carry that wooden plank with you to the airports. Finally, I figured it out. So you can put it on it and sleep on the plank. That's brilliant.
And it works. It's like and honestly, that's what we do. We come up with workarounds.
Exactly.
And we do the same thing in the code, and it's the things that lead our code to be more brittle.
As somebody said, make it foolproof, you'll find a bigger fool.
Yep.
So absolutely, that beats every single time.
Nothing is foolproof to a sufficiently talented fool is another version of that.
There you go. And I think we already talked about the next principle in way of talking other things. But just to reiterate it, to really give meaningful names for anything we abstract out, whether it's variable name or class name or function name or component name, naming is one of the most difficult things to do. And
it's one of the two hard problems in computer science.
Exactly. And in all honesty, every time I name something, somebody comes back and says there's a better name for it. And that can be a little dissuading and discouraging. But at the same time, I think over time, we can actually get better at really giving names if only we try, at least even marginally so, rather than, and to the great extent though, this is a little bit shocking though, but we take a bit of a pride in writing cryptic code. I think this started out in the early days of programming, when programming was more of an esoteric field. And this is one thing I think it's important for us to just wake up and realize that programming is a very important part of the society today. And we can hurt people, we can bring down societies by doing a poor job. And so it's no longer really the field where a group of little, small group of people get together and do whatever they want to do. And I'll honestly say one thing. Over the 30 years I've been in the field of programming, a little more than 30 plus years, I have actually served as an expert witness in 3 lawsuits so far.
Interesting.
Not that I'm taking pride of doing it, but occasionally somebody would contact me and say, hey, we know you are known in the industry. We want you to serve as an expert witness. One of the more recent ones was out of Washington, D.C., when a company contacted me and said, we are suing this consulting company for creating unmaintainable code. So we want you to evaluate the code and tell us if the code is of poor quality. And of course, for the time, they would pay me for the time, but it's an unbiased opinion they want under the code of law. Well, they send me the source code. This could not have been easier. I'm not making this up at all. This could not have been easier because they send me the source code and I'm in denial that any human being would have written this actual code. And I wanted to say these are really bad quality code, but that would be, one guy, Venkat's opinion, right? But I did a very quick Google search and I found a coding guideline on Oracle's website. And I'm not even kidding with you. The rest of the afternoon for me was to code the line number in their source code, to code the line number on the coding guideline page, and outline what the violation was. And I filled up, I don't even remember now, maybe 10 pages of such violations. And then I said, if you need more, please let me know. And that was an easy way to show how terrible the code quality was. But I think this is one of the things I'm really worried about is because of the nature of software, I think we are dragging ourselves to becoming a regulated industry, whether we like it or not. And I'm not happy to say this honestly, but I think we are going to be the people leading to that, unfortunately, because we are going to invite the Congress to talk about how really poor our practices are. And we are going to place a governing body and put regulations on ourselves, and we're going to repent it. So unless we wake up to correct ourselves, the adults are going to walk in to correct us. And I think we should really be careful about it, I think, in the long run.
Wow, that is, yeah, I worry about that for a number of reasons, if nothing else. Using history to predict the future, our legislatures have not generally understood technology very well.
and would never.
Yeah. And I wonder how long it's going to be before developers have to carry liability insurance the way doctors have to carry liability insurance, like employed developers in the same way employed doctors. Because obviously as a consultant, I had E&O and liability and all of that. But yeah, that is that's going to be interesting. Hopefully we can self-govern as an industry. And we've got about 10 minutes left. There are so many little rabbit holes I want to dive down. When you're talking about giving meaningful names, it reminds me of the first time I truly embraced DDD and wrote robust domain models that followed the ubiquitous language of the domain. And literally the product owner could read and understand my code. And that was eye-opening when I give a non-technical person some code and they're just like, yeah, this is right, but that needs to be doing that. And it was, it requires a license to cut somebody's hair, but literally anybody can code.
Yeah. Well, what you mentioned just reminded me of one thing I would never forget. I had a chemical engineer sit next to me and I was looking at the code and I said, well, here's an element. And the chemical engineer looked at me and I could see the pain through his eyes. And I said, is something bothering you? And he said, I don't understand why that would be an element. And I said, well, it's an element in this particular unit. And he's like, I don't understand. And then I realized, oh my gosh, you're a chemical person. The word element means something very different to you than to me as a programmer. And then I changed it as, something a little bit more meaningful, computer science, than the domain name element. He's like, oh, so again, this kind of comes back to that confusion. We really need to think about the domain when we code, especially when, programmers that you have are, domain experts as well. It really helps to deal with it properly. And in that regard, we talk about ability to improve the code, and we often talk about refactoring. And I know earlier you mentioned, Michael, that one of the most exciting non-technical book you have read is, among a lot of things you have read, is the Design of Everyday Thing. For me, in all honesty, that book is William Zinzer's book on writing well. That book blew my mind. And when I read On Writing Well, it's a 30-year-old book, and Mr. Zinzer passed away a few years ago, but he left something absolutely phenomenal. In that book, he talks about how to write good English for writing nonfiction. But honestly, as I was reading the book, every step of the way, I was telling myself, my goodness, Zinzer is not talking about writing English. Well, he was. He's talking about writing code, because he outlines 4 principles for writing good English. He says simplicity, clarity, brevity, and humanity. And I was thinking, oh my goodness, those are the 4 things we struggle to do when writing code as well. How many times people tell us, make your code simple, make it clear. And why is code not clear? Because it lacks flow, excessive mutability, too many locks and constructs related to programming, accidental complexity in the code that takes away the essence of what the code is doing. So, and brevity, right? And brevity, to me, I like to discern between 2 words. I don't want my code to be terse. I want my code to be concise. And I use these 2 words in English. Terse is short and waiting to hurt you. Concise is short and easy to understand, easy to maintain. So I want the code to be concise, but not to the extent of where it is being terse. And then finally, of course, humanity. This goes back to what we started with earlier, is to think of the fellow human being who would maintain the code after we push that into the repository. I think William Zinzer's book helped me to, more than write good English, it actually helped me to write better code in the long run. So I'm ever thankful for him to have written that book. And I think that's one of my books that really helped me to become a writer, both in terms of writing books, but also in terms of writing code as well.
And I need to be better about that. I often mistake terseness for conciseness. But that goes back to something you said right at the beginning of this, that terms are so important and terms guide our thinking. I want to throw one more example, an idea I picked up from Llewellyn Falco, and it was using the right terms. And so you talked about clarity and conciseness and complexity and all of this and cleverness. One of the biggest realizations he had was he renamed the error message in his code, because think about that. If we're ginning up an exception, then we're going to give it an error message, and the error message is what happened. And so he just did an experiment, and instead of having an error message property, he had a help message property. And suddenly all the developers, when asked to give an error message, they gave an error message. When asked to give a help message, they gave something that was helpful to the end user. And it was the exact same thing that was communicated, but it was communicated a lot better. And then to your point on conciseness versus curtness or terseness, it reminds me, I think it's a quote by Albert Einstein, or at least it's attributed to him, rightfully or wrongfully, that everything should be made as simple as possible, but no simpler.
Yep. Well, the last thing I want to actually talk about is something I get tickle out of doing, and I want to encourage those who are in the call to please take a minute to respond to this, because I always love looking at this particular question. I'm going to ask two questions. Here's my first question, and then please enter into the chat. And what you can enter into the chat is, one of the two words, yes or no. So here's my first question. Do you think long functions or long methods are a good idea, right? That's the first question. And I see no popping up on the chat, as you can see, right? So we see this no pop up continuously. And okay, there's always that it depends, right? He should be a consultant, right? We all as consultants know to say it depends. And again, of course, how long is long? That's a really good question as well. So we saw an overwhelming number of no. So let me ask you a second question, and I asked this question sincerely, though. My second question is, recently, have you seen long functions in your code base? Somebody in your company did this. Somebody in your company wrote it. Have you seen? And notice that response now is almost all overwhelming yes, right? So that's what I always say as a cognitive dissonance. And this pains me, right? Because this is something we all know not to do. And yet we see this all over. And here's the unfortunate thing, right? Nobody on this call is writing long methods, but the people writing the long methods are at work right now, making those methods longer as we speak. So, and there's nothing we can do about it, right? So the question really is, if there's one thing, just one thing I would say, if we can do in our industry, it is to really take a deep breath and slap. Literally slap. You say, oh, no, let me clarify it. I'm not promoting violence. SLAP stands for single level of abstraction principle. So single level of abstraction principle is the last thing I want to really mention here. And every single day, Michael, there have been developers who come to me and say, well, I don't like to write short methods because then there are too many short methods in my application. And I realized people are looking at the length of the method with the measuring tape. And what we need to do is not look at the size of the method. I'll share with you a story I would never forget. Somebody came up to Dave Thomas, the pragmatic programmer, and said, could you tell me about my code quality? And Dave said, sure, show me the code. And the developer pulled up the code and showed it. And Dave said, reduce the font size to 1 point. And the developer looked at Dave and said, are you serious? And Dave was like, yeah, reduce it to 1 point. And the developer reduced it to 1 point. And Dave said, turn the monitor 90 degrees. And then he said, you see the mountain peaks over there. And his point was the number of levels of nesting in the code is inversely proportional to the quality of the code. And this really goes back to SLAP, the single level of abstraction principle. So one thing I strive for today is not an arbitrary number of lines of code. I don't care if your function has 70 lines of code in it. What I care about is all the code in a function in a single level of abstraction, a single level of detail. And if you're able to give me a code with a single level of detail or abstraction in it, then the code becomes easier to maintain. And naturally, we tend to avoid those long functions over time. And I think that's one of the things we as developers can promote in our own team in a very constructive way, not to really belittle or, insult or shame people who are writing long methods, but to really refactor the code to bring in that single level of abstraction. And the more we do it, I think we can promote a better quality code in the long run.
Yeah. Oh, definitely. And there's so much great stuff in here, by the way. Just looking at the chat here. Junior coders, write code, senior coders, delete code. And somebody else worked somewhere where you got paid based on lines of code. I've been on those projects. We never deleted anything. We would, if we had a bunch of code that was no longer needed, we would just wrap it in if false. We literally did that a lot.
I gotta go take a shower now.
It was awful. It was Your Code as a Crime Scene is a good book that discusses code understanding. That's really good. A few other things I'll throw in, by the way. I really like the way Tudor Girba thinks about code. He talks about humane software development, and I don't think that's something we think about enough. There was one other thing that I was gonna throw in there as well, and it has already come and gone in my mind because we've got so many nuggets here. You know, and yeah, you really kind of hammered it home, or you really kind of built a good foundation. Like foundationally, if we want to write better code, we have to care. I actually, a link to Ken Beck's Rules of Simple Design. Write clear code instead of clever code. That's super valuable. Meaningful names and the single level of abstraction principle. And it's, you know, and I think a lot of the metrics really support these ideas. But sometimes we tend to overemphasize the metrics themselves, and we get into these hard numbers. Well, 80% code coverage, and you know, no cyclomatic complexity over 3, and things like that. And I think we need to look at this a little more holistically. But we are coming right up at the end of time, and we got through so much valuable stuff. And by the way, everybody who has just been blowing up the chat feed, this has been just so wonderful. So many additional great nuggets. I feel like we're almost mobbing on you know, defining this solution. But Venkat, I want to leave you with kind of last words. Let you kind of close this down. And as a reminder, of course, you'll be able to see Venkat in person this fall at some of the live events, and as well as some of the training opportunities that are going on constantly. In fact, I'm pretty sure there's one happening right now on nofluffjuststuff.com. Check that out, because there's so much value in there, and I cannot overstate how much just knowing these folks and spending time around them has shaped my career. But Venkat, I'm going to hand it over to you, but I want to thank everybody for taking the time to join us today, and I hope everybody has a wonderful weekend, stays healthy, stays safe, and again, over to you.
I want to conclude by saying, you know, that's one of the most exciting things for me in being in this field, is that the ability to continuously learn. There's not a moment of dullness, you know, where you wake up and think that, oh my gosh, I think I'm done. No, it's never done. There is so much to learn and to relearn and to improve. And that's one of the things I really, really enjoy, is having this ability to learn from the community, from the developers around us, both young and more mature and senior, if you will. And I think that's brilliant. And I definitely want to thank everybody who joined on the call today. And I'm hoping that I will be able to interact with most of the people in person when the conference begins to happen, not too long from now. I want to wish everybody a very safe time, and get vaccinated, get into good health, and stay well and take care of your loved ones. Looking forward to seeing you all soon.
Let me put it this way, Mr. Amos.
Wonderful. Thank you so much. I'm going to play you out with some standard out the wrapper on testing. Everybody, thank you so much. Stay healthy, stay safe, and stay sane. See you next time.
Myself to the fullest possible use.
T-E-S-T-I-N-G, that's for them but not for me. I know I write perfect code, I don't need no TDD. Nope. All the tests are so flaky, 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 flaky. Test suite is so janky, 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 janky. T-E-S-T-I-N-G, find out what it means to me. I know I write perfect code, screw it, go straight to release. All the tests are so flaky, flaky,
ship it, right?
Test suite is so janky, 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 janky. Code coverage, T wants to hit 100. Why? My headless browser cannot find the fucking button. Of course. Well, I'll just make the test sleep a second. Do anything to keep up our percentage. mock returns, fake API calls.
Oh, I
These tests
sworn I
don't
think there
really
might be
test
some
anything
language.
at all. So slow, I eat a snack while they run, and it does nothing. QA is still finding bugs. I don't wanna write tests cause I'm lazy, but my code reviewer snitched and my whole team made me. I swear code shift hates me cause it always fails my build with one test flaky. Made a small change, like 3